All right, welcome to the deep dive. We've got a ton to unpack today. You guys have sent in so much great material. It's all about managing and deploying Postgres databases, and particularly this idea of, well, it's being called cloud neutrality, so
Yeah.
we got to figure out what that even means, right?
Absolutely.
And of course, we'll be wading through all the talk about Kubernetes, CloudNativePG, and I gotta say, there are a lot of related concepts. It can be tough to keep it all straight.
It definitely can.
So our aim in this deep dive, and I think you'll appreciate this, is to really boil it down to the essentials, help you grasp the key takeaways without getting bogged down in all the technical jargon.
We'll try to keep it clear and simple.
Because let's face it, this stuff is changing so quickly, it's easy to feel overwhelmed.
Yeah, it's a hot topic, for sure. A lot of organizations are wrestling with these same questions right now. I mean, just look at the database market in general. It's booming. And relational databases like Postgres, they're leading the charge.
Makes sense, right?
And I think a big part of that growth is being driven by these major cloud providers and the whole DBAS thing, database as a service.
DBAS, right. It's everywhere you look these days.
Right.
But here's the interesting thing, and this is what caught my eye in the material you sent. Even with this huge push towards the cloud, a lot of companies that rely heavily on Postgres are turning towards, get this, Kubernetes.
Kubernetes, yeah.
And they're doing it to achieve, you guessed it, cloud neutrality. The idea, at least as I understand it, is to avoid getting locked in with one specific cloud vendor, and to gain more flexibility in how they deploy their databases. So that's what we're going to be digging into in this deep dive. How is this transition happening? What are the key technologies? What are the considerations? And most importantly, what does it all mean for you?
A lot to cover.
Yeah, a lot to cover.
And central to all of this is this thing called the CloudNativePG stack. It essentially combines the power of Kubernetes with the, let's face it, rock-solid reliability of PostgreSQL, and then adds this extra layer of automation with the CloudNativePG operator.
Yeah.
And what you get are database solutions that are both portable, you can move them around, and highly scalable, which means you can grow them as your needs change.
Okay, so to really understand this whole cloud neutrality thing,
Right.
maybe it's helpful to kind of step back and look at how Postgres deployments have evolved over time.
I like that.
Back in the early 2000s, running Postgres meant you were probably installing it directly on bare metal Linux servers, right?
Right.
Often using hardware RAID for some added resilience.
Yeah.
Back then, it was all about that direct control over the hardware.
Absolutely.
You had to squeeze every ounce of performance out of those machines.
Yeah.
And for some organizations, and I think this is important to remember, on-premises deployments, even today, still make a lot of sense, especially if they have those really specific requirements around security, compliance, maybe performance too.
Yeah, you're absolutely right. If you need that granular control over your hardware, over your security, or maybe you have strict data sovereignty regulations to comply with, staying on-premise is still a solid option.
Yeah, it's not going away anytime soon.
Yep.
But then things started to change. We moved into the late 2000s, and we saw the rise of IaaS, infrastructure as a service.
Right.
And this was a big shift. All of a sudden, you could rent virtual server storage in the cloud.
Yep.
So it definitely gave you more flexibility in getting your database up and running initially, those day one operations, as they're called.
Yeah, and tools like Terraform and Ansible came along and made it even easier to automate that initial setup.
Right, right.
But here's the thing. While IaaS made provisioning faster and, more flexible, all those ongoing operations, the day two stuff, keeping the database highly available, doing maintenance, scaling the resources up and down, optimizing performance, that still fell largely on the shoulders of the database administrators, the DBAs.
Yeah, the unsung heroes.
Exactly. And these tasks often weren't very well integrated with the broader infrastructure management tools.
Right.
And, a lot of people thought pay-as-you-go models would lead to cost savings.
Yeah, that was the promise.
But sometimes those costs became surprisingly complex.
Yeah, I've heard that too.
And then this concern about vendor lock-in started to emerge.
Oh, right. You're stuck with that one provider.
Exactly.
Interesting. One of the sources actually pointed to Heroku as an early example of PaaS, platform as a service.
Oh, yeah, good old Heroku.
It really gained traction around, I think it was 2010, especially with those Ruby on Rails developers.
Right.
And it really boosted Postgres adoption because Heroku took care of so much of the underlying infrastructure.
Right, they abstracted it all away.
And that kind of paved the way for what we have now, which is the DBOS era,
The DBOS era, that's right,
database as a service.
which has just exploded in popularity, especially since around 2013. And now you have cloud providers handling a big chunk of the operational burden.
So less for the DBAs to worry about.
Less for the DBAs. They manage the infrastructure, the operating system, the Postgres server itself. And this allows developers to focus on what they do best, which is developing applications.
Right, building the apps, the features, all that.
Exactly.
And we're talking big names here, right? Amazon RDS for Postgres, Google Cloud SQL for Postgres, Azure Database for Postgres.
All the big players.
And even specialized solutions like EDB Postgres AI Cloud Service.
Right, there's a whole ecosystem now.
And these services, they really do make things simpler. They offer built-in high availability, disaster recovery, monitoring, often with geographic redundancy.
It's pretty amazing what they can do these days.
But, and this is the caveat, our sources point out that this convenience comes with trade-offs. You gain reduced complexity, sure, but you might lose some of that direct control over the Postgres backend.
They're trading control for convenience.
Exactly, and it brings us back to that concern about vendor lock-in.
Yep, it always comes back to that.
And data portability, this idea that you might want to move your data between providers, maybe implement a multi-cloud or hybrid solution without it being a huge headache.
And the EU Data Act, which is mentioned in some of the material you sent, really highlights the importance of data portability. It's not just about regulations, it's about giving organizations more control over their data.
And that's where this idea of cloud-neutral Postgres comes into play.
Right,
It's about addressing these complexities, right?
Yeah.
Managing Postgres across different environments.
And finding a way to do it efficiently.
Exactly.
So a cloud-neutral approach, what it really aims to provide is this highly portable infrastructure
Portable.
that allows you to easily move between cloud providers or even back to on-premises.
Gotcha.
It's about supporting both those initial day one setups, getting things up and running, and then all those ongoing day two operations, keeping it running smoothly without compromising performance or manageability.
So how do you actually achieve that?
The key is leveraging open source technologies and standardized APIs. The goal is to avoid that vendor lock-in, reduce the operational overhead, and keep that flexibility to choose the best infrastructure for your specific needs.
And Kubernetes, according to the sources you sent, seems to be the cornerstone of this whole cloud-neutral vision.
Kubernetes, yeah.
For those of us who might not be Kubernetes experts, can you break down how it works as this cloud-neutral platform?
So Kubernetes essentially provides this standard way of managing your infrastructure and your applications. And these applications, they're packaged in these things called containers, which are basically like lightweight virtual machines.
Okay, so it's like a container ship, but for software.
Yeah, kind of.
Yeah.
The great thing about Kubernetes is that it has this really modular and extensible design. It's built to be fault tolerant, which means it can handle failures without everything crashing down.
That's reassuring.
And it really aligns well with the whole infrastructure as code philosophy, which is all about managing your infrastructure through code, just like you would manage your application code.
That makes a lot of sense.
And because of all this, Kubernetes can be deployed pretty much anywhere, from your own bare metal servers to those virtual machines in the cloud, managed Kubernetes services from the big cloud providers, and even enterprise platforms like Red Hat OpenShift.
So it's pretty versatile.
It is, and that versatility is key to its cloud neutrality. It gives you options.
Okay, so Kubernetes provides that foundation for cloud neutrality at the infrastructure level.
Right.
But our sources emphasize that managing a complex stateful application like Postgres within Kubernetes that has its own unique challenges.
It does.
So why aren't those standard Kubernetes resources like deployments and stateful sets enough for managing Postgres?
It's a good question. And it really gets at the heart of what makes stateful applications like databases so different. Kubernetes is great at managing stateless applications, like web servers or APIs, using those deployments. Those are easy to replace if something goes wrong.
Right, because they don't really store any data.
Exactly. But stateful applications, they have all these requirements around data persistence, making sure that data is stored safely and reliably, ordering of operations during scaling or updates, and even network identity.
So it's a whole other level of complexity.
It is. And stateful sets, they try to address some of these concerns, but for a database like Postgres, which has all its own sophisticated mechanisms for things like replication, failover, backup, and recovery, you really need a more specialized approach.
Makes sense.
There's this analogy that's often used. It's like treating stateless applications as cattle, easily replaceable. But databases are more like pets. Each one is unique and needs more care and attention.
I like that.
But one of the sources actually takes this analogy a step further, and I love this. They suggest that for Postgres, because it's so powerful and resilient, maybe the analogy of managing a herd of elephants is more fitting.
A herd of elephants. That's brilliant. It really captures the essence of managing something that's both individually complex and collectively powerful.
Yeah. And you can see why a specialized approach like CloudNativePG becomes so essential.
So an operator steps in to provide that specialized management, right?
Exactly.
Can you explain the operator pattern a bit more? What does it actually do?
So at its core, an operator is a way to extend Kubernetes, to give it more capabilities. You do this by adding custom resources and controllers.
Okay.
It's essentially taking all the operational knowledge of how to manage a specific application, like Postgres, and encoding it directly into Kubernetes.
Yeah.
So instead of relying on, manual scripts or external tools, you define what you want your Postgres cluster to look like using these custom resources.
Mm-hmm.
And the operator acts as a controller, constantly working to make sure that the actual state of your cluster matches that desired state.
So it's like having an expert Postgres administrator built right into Kubernetes.
That's a great way to put it.
And that brings us to CloudNativePG, which is highlighted in the sources as a CNCF sandbox project. It's actually on its way to incubation, and it's an open source Kubernetes operator specifically designed for Postgres. What makes CloudNativePG stand out from the crowd? Why is it so popular?
There are a few reasons, really. Firstly, it's got this strong community governance. EDB, the company that originally created CloudNativePG and put a lot of work into it, they actually donated the intellectual property to the CloudNativePG community back in May 2022. So now it's being managed openly by a vendor-neutral group, which is really important.
That's huge.
Yeah, it means no single company controls it. And secondly, it's got this status as a CNCF sandbox project, which means it's aligned with all those cloud-native best practices.
Makes sense.
And it shows it has the potential for wider adoption, becoming part of that whole cloud-native ecosystem.
So it's not just some niche project?
Exactly.
Yeah.
And if you look at its popularity on GitHub, it's got tons of stars, downloads, and it's being adopted really quickly. And another thing is it has really good documentation, which is so important for open source projects.
Yeah, I've tried to use some open source projects where the documentation was, shall we say, lacking.
Yeah, we've all been there.
It can be a real pain.
And CloudNativePG is designed to be truly Kubernetes native, which means it fully leverages and extends the Kubernetes API. It's not just tacked on as an afterthought.
Right, it's built for Kubernetes from the ground up.
Exactly. And it also collaborates with the Kubernetes storage project, which is really important for dealing with the specific demands of database workloads.
Okay, so it's got the community backing, it's got the integration with Kubernetes, it's got the documentation. What about the practical benefits? What can you actually do with CloudNativePG to manage Postgres on Kubernetes?
Well, for starters, it offers this really powerful feature called automated failover and self-healing. It does this by integrating directly with the Kubernetes API. So if your primary Postgres instance goes down for whatever reason, CloudNativePG can automatically promote a replica to take its place.
So no downtime.
Ideally, very minimal downtime. You don't have to manually intervene or use any external tools. It just happens automatically.
And you mentioned earlier declarative management.
Right.
Can you explain how that works with CloudNativePG?
Yeah, so declarative management is this idea that instead of running a bunch of commands, you define what you want your Postgres cluster to look like in a configuration file. And CloudNativePG takes care of making it happen. It's like you tell it what you want and it figures out how to get there.
So you don't have to worry about the how, just the what.
Exactly. And you can manage almost everything this way. Configuration settings, user roles, the databases themselves, even extensions.
It sounds incredibly powerful.
It is, and it doesn't stop there. It handles scalability too. You can just adjust the desired number of Postgres instances in your configuration, and CloudNativePG will scale your cluster up or down accordingly.
No need to manually provision new servers?
Nope. It also automatically manages the creation of read-write services, which are used to route traffic to the primary instance, and read-only services, which distribute those read workloads across your replicas, improving performance. And for data consistency, it supports synchronous replication, which means that transactions are committed on the standby replicas before they're acknowledged on the primary.
So that's crucial for preventing data loss in case of a failure.
Absolutely.
What about those more advanced deployments? Like if you're running Postgres across multiple Kubernetes clusters, maybe in different clouds.
CloudNativePG supports that too. It has this concept called replica clusters, which allows you to create distributed Postgres topologies across multiple Kubernetes clusters. This is incredibly valuable for multi-cloud and hybrid cloud scenarios because it lets you implement things like disaster recovery and geo-redundancy, making your database more resilient.
Okay, so that covers the deployment side. What about backup and recovery?
That's another area where Cloud Native PG excels. It integrates with this tool called Barman Cloud for continuous backup to object stores like Amazon S3, Azure Blob Storage, and Google Cloud Storage. And it offers point-in-time recovery, which means you can restore your database to a specific point in time. It also supports backups using volume snapshots, and even allows backups to be taken from the standby replicas, which reduces the load on your primary instance.
So it's pretty comprehensive in terms of backup and recovery options.
It is, and it doesn't stop there. It also supports rolling updates for both Postgres minor versions and the operator itself, minimizing downtime during upgrades. And it comes with a built-in Prometheus exporter for monitoring key database metrics. Plus, it integrates with Cert Manager for managing those TLSSL connections, and it even provides declarative management of PG Bouncer for connection pooling. And for those of us who love the command line, it even has a kubectl plugin that simplifies common cluster management tasks. And its support for local persistent volumes with PVC templates that gives you more direct control over how your data is stored.
Okay, so Cloud Native TG handles a lot of the heavy lifting when it comes to running Postgres on Kubernetes.
It does.
But how does all of this translate into achieving that cloud neutrality we've been talking about? How does it actually help?
That's the beauty of it.
Yeah.
By defining your Postgres cluster as a Cloud Native PG cluster resource, you're essentially creating this blueprint that can be consistently deployed and managed across any Kubernetes environment, whether it's on premises, in a public cloud, or in a hybrid setup.
So it's like a universal language for Postgres on Kubernetes.
Exactly. And Cloud Native PG handles all those crucial day two operations, no matter where Kubernetes is running. Plus, Postgres has this built-in feature called streaming replication, which ensures data portability. So you're not tied to a specific cloud provider's database service.
You can take your database and move it wherever you want.
Exactly.
You mentioned scheduling capabilities earlier.
Right.
How does Cloud Native PG leverage those advanced features of Kubernetes?
That's another cool thing. Kubernetes has all these features like node labels, taints, affinity rules, and tolerations.
That's complicated.
It can be, but basically these features give you this fine-grained control over where your Postgres workloads are deployed. You can isolate them on dedicated nodes or even spread them across different availability zones for even more resilience. But at the same time, you can still integrate them logically within your Kubernetes cluster.
So you can have the best of both worlds, isolation and integration. It seems like you could even use Cloud Native PG to build your own internal database service, like a D/S for your organization.
Absolutely. Because it's built on standard Kubernetes resources like load balancers, you can use Cloud Native PG to create a cloud-neutral D/S solution. So you can expose Postgres safely to internal teams or even external clients.
And there are actually examples of this out there, right?
Yeah, there are. IBM Cloud Pak, EDB Postgres AI Cloud Service, Tembo, they're all using this approach to build database services.
Okay, so that covers the cloud side of things. But our sources also discuss this idea of the return of bare metal Postgres in the context of Kubernetes.
Bare metal, yeah.
I thought Kubernetes mainly ran on virtual machines.
That's a common misconception. While Kubernetes can certainly run on VMs, it actually works just as well, and often even better, on bare metal servers.
So no virtualization layer.
Exactly. By running directly on the hardware, your containers can take full advantage of all the resources available without that virtualization overhead.
So potentially better performance.
Potentially, yeah, especially for demanding workloads like databases. And what's really interesting is that EDB's early experiments with bare metal Kubernetes actually led to the development of Cloud Native PG. So it's come full circle.
So it's like Postgres is coming home.
In a way, yeah. And this opens up some really exciting possibilities for DBAs. They can run Postgres on their own hardware, replicate across clusters, create these hybrid cloud solutions.
So maybe we'll see a shift away from always relying on the public cloud.
It's definitely possible. Cloud Native PG makes it a viable option.
Okay, so this is all really interesting from a technical perspective, but for the Postgres DBAs out there, what does all this mean for their careers? The sources use this phrase, career crossroads. What do they mean by that?
It's a great question. I think the increasing adoption of Kubernetes is presenting Postgres DBAs with a real choice. They can embrace this new technology, try to avoid it, or maybe even deny its relevance. But I think, and the sources seem to agree, that embracing it is the best path forward. Because while deploying a basic Postgres cluster on Kubernetes is becoming easier, the deep expertise that these DBAs have, that's still incredibly valuable.
They're not going to be replaced by robots anytime soon.
Not at all. There's this whole new world of opportunities for DBAs who can combine their Postgres knowledge with an understanding of Kubernetes. That's a lot like the transition they went through when we moved from bare metal to virtual machines.
So what specific Kubernetes knowledge do they need to be successful with Cloud Native PG?
They don't need to become Kubernetes gurus overnight. The key is to focus on the core concepts. Things like understanding what pods and containers are, how networking works in Kubernetes, specifically services, how storage works, storage classes, persistent volume claims, persistent volumes. And it's important for them to be able to collaborate with the infrastructure admins on things like infrastructure as code, GitOps, TLS certificates, monitoring with Prometheus, and logging.
So it's a collaborative effort.
It is. And I think based on the sources, investing a month or two in learning these essential skills can really pay off for DBAs.
So it's not an insurmountable hurdle.
Not at all.
That was for organizations that are trying to decide if this cloud-neutral approach with Cloud Native PG is the right fit for them. What are some of the things they should consider? What are the key decision points?
Well, one of the biggest factors is going to be whether they have the Kubernetes expertise in-house. If not, they'll need to either develop it or bring in a partner who can help them. And the level of expertise they'll need depends on the type of Kubernetes platform they choose. Do they want to manage everything themselves with upstream Kubernetes, or do they want to go with a managed service like Google Kubernetes Engine or Amazon EKS?
So it's not a one-size-fits-all solution.
Exactly. And it's really important to involve the Postgres DBAs in this decision-making process from the very beginning. If the DBAs are resistant to change, or if the organization just doesn't have the Kubernetes skills, it might make more sense to stick with those more familiar options like bare metal, VMs, IaaS, or even DBaaS.
So it really depends on the specific circumstances of the organization.
Absolutely. I'm curious though, some of those sources we reviewed mentioned that there is a bit of a learning curve with Kubernetes. Do you think that's a big barrier to entry for organizations looking at Cloud Native PG, and are there any trade-offs to consider in terms of operational complexity?
It's a fair question, and it's something that organizations definitely need to weigh. But one of the points that really struck me in the sources is that this trend towards cloud neutrality isn't just being driven by organizations that have these large, dedicated DBA teams. There are a lot of organizations that have embraced Kubernetes, but maybe they don't have those specialized DBAs.
You're right. I've seen that too.
And they're using Cloud Native PG to build these internal DBA offerings for their developers and other teams. It's like they're finding this middle ground between traditional infrastructure management and a fully managed cloud DBA.
It's like a DIY DBase.
Exactly.
Which is pretty cool.
Yeah, and it's particularly popular in larger enterprises and in Europe, where there's still a strong preference for on-premises infrastructure.
And I think the fact that Cloud Native PG can provide this really good isolation of workloads, even on those bare metal Kubernetes nodes, that's a big selling point.
It gives you that peace of mind that your database is secure and performant.
Exactly.
And what about EDB? They were the original creators of Cloud Native PG, so what's their role in all of this now?
They're still very involved. They're actually a silver member of the CNCF, and they're the only Kubernetes certified service provider that's actively contributing to the development of PostgreSQL. So they're deeply embedded in this whole ecosystem.
So they're still heavily invested in Postgres on Kubernetes.
Oh, yeah. And they even offer a long-term supported version of Cloud Native PG called EDB Postgres for Kubernetes, which includes some extra features like Oracle compatibility through their EDB Postgres Advanced Server and support for active workloads with their EDB Postgres distributed for Kubernetes.
So they're providing both community support and enterprise solutions.
Exactly.
Okay, so let's try to tie it all together.
Yeah, let's recap.
Kubernetes is transforming how we deploy and manage Postgres databases, and it's offering a path towards this cloud neutrality. But the best approach for any particular organization, that really depends on their needs and the skills they have available.
Right. It's not a one-size-fits-all situation.
Some of the sources actually provided some helpful tables summarizing the key considerations, things like vendor lock-in, cost predictability, those sorts of things. They also looked at the infrastructure side, hardware costs, bare metal support, and all those Postgres-specific factors like business continuity, data portability, configuration control, all across different deployment models, from on-premises to ILS to dbus to cloud-neutral solutions.
It's good to have all those options laid out so you can make an informed decision.
Exactly.
And what I think Cloud Native PG brings to the table is this really robust, high-performance, standardized way to run Postgres across all these different environments. And it's all driven by that declarative configuration, which we talked about earlier.
So less manual work, more automation.
Exactly. It empowers DBAs, helps them avoid vendor lock-in, and keeps them in control of their data and performance.
Sounds pretty appealing.
It is. And as more and more companies look for alternatives to relying solely on the public cloud, I think Cloud Native PG offers this really compelling solution because it's scalable, it's future-proof, and it even supports this potential return to on-premises deployments.
It's like coming full circle.
It is.
So for you, the listener, the key takeaway here is that cloud neutrality for your Postgres databases is achievable. Kubernetes and Cloud Native PG make it possible, and it gives you a lot more control and flexibility.
Yeah, it's worth exploring.
We know from the sources you've shared with us that you're probably dealing with some of these challenges.
Right.
Managing Postgres in all these different environments.
Yeah.
Maybe you're worried about vendor lock-in or the overhead of managing all these different deployments.
It's a common concern.
So here's something to think about. How could a shift towards cloud neutrality address those specific challenges for your organization? What are the specific benefits you could gain? And what are some concrete steps you could take to explore Kubernetes and Cloud Native PG further?
Start by checking out the Cloud Native PG website.
Yeah, great suggestion.
They have excellent documentation, really thorough,
Yeah.
and you can find links to that in the show notes, along with the GitHub repository.
And if you want to get more involved, check out the Cloud Native Computing Foundation and the Data on Kubernetes community. Those are great places to connect with other people who are working with this technology.
They are. And if you need enterprise support, take a look at what EDB is offering. They've got some really interesting solutions.
Great advice. And before we wrap up, here's a final thought to chew on. With Kubernetes getting more mature all the time, and projects like Cloud Native PG gaining momentum, are we at the beginning of a major shift in how databases are designed and deployed? Could this be the start of a new era where organizations have more control over their data infrastructure than ever before?
It's an exciting time to be working with databases, that's for sure. Thanks for joining us for this deep dive.
Thanks for listening.